Good morning and welcome to this Room 2003 Science Lightning Talk covering the topic of I am your host, Mr. Wells. Subscripts are everywhere because substances are everywhere. For example, water has a chemical formula of H2O and a subscript of 2. Ammonia is in the cleaner that we use for cleaning the desks during COVID. Baking soda, hydrogen peroxide is probably in your medicine cabinet at home. Nitrogen gas is in the air you breathe. Table salt, obviously, makes stuff tasty. And magnesium is in dark chocolate and broccoli. Subscript literally means that which is written underneath. And I mention this because I think it will help kind of lock it in if you're struggling to get the idea of subscript. It literally means that which is written underneath. It comes from the word parts sub, meaning underneath, and scribere, meaning to write. So what is the chemistry definition or description of a subscript? In chemistry, we say they are the little or the below numbers in chemical formulas that tell you how many atoms of each element are represented by the formula. Another way of saying that is subscripts tell you the number of atoms of each element contained in a molecule or formula unit of the substance represented by the formula.
What? Let me explain. No, there is too much. Let me sum up.
I think the best way to sum up is to walk through some examples, and I think we have 4 or 5 examples here. Let's start with water. With water, we notice the subscript of 2 following the hydrogen. It is written a little bit beneath the hydrogen and to its right, but also notice that even though the O does not have a written subscript, it is implied that it is 1. Anytime you see the element symbol without a subscript, it means that there is 1 atom of oxygen there. So if we were to rewrite this and break it down, we could say there are 2 hydrogen atoms because of the subscript of 2 and 1 oxygen atom because of the implied subscript of 1. Let's look at baking soda and apply the same concept. If we were to rewrite this, we could write with 1 sodium because of the absence of a subscript here, 1 hydrogen, 1 carbon, and 3 oxygen atoms because of the subscript 3. One more straightforward example, hydrogen peroxide. We could rewrite hydrogen peroxide as HH for the 2 hydrogen atoms, OO for the 2 oxygen atoms, HHOO. Now, sometimes we encounter chemical formulas involving parentheses, and this is a little more work, but the concepts are still the same. Let's deal first with the subscript outside the parenthesis 3. We could rewrite this as aluminum and 3 nitrate groups. So we could rewrite it with 3 of everything inside the parentheses. Now let's deal with the 3's inside the parentheses. We could rewrite this as aluminum, NOO, 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 for a total of 1 aluminum atom, 3 nitrogen atoms, and 9 oxygen atoms. One more parenthesis example, aluminum potassium sulfate. Again, let's deal with the 2 outside the parentheses and rewrite that as aluminum potassium with 2 sulfate groups. And let's further break that down by getting rid of the subscript and writing aluminum potassium, SOOO, SOOO, for 1 aluminum atom, 1 potassium atom, 2 sulfur atoms, and 8 oxygen atoms. Well, that's all the examples that we have. Thank you for joining us for this Room 2003 Science Lightning Talk covering This is Mr. Wells signing off. As always, be safe and do science.